So, because not always is it as easy as just adding 2 plus 4 plus 6 plus 8 plus 10 plus 12, we come down to math and noticing patterns. And so let's just say we have to add up all the numbers from 1 to 100. And I'm not going to write all these out, but you come to 100, 99, 98, 97. And math is all about noticing the patterns. And so if you notice that 1 plus 100 and 2 plus 99, 3 plus 98, and 4 plus 97, if you keep adding those are all equal to 101, all those pairings. So we had 101 repeatedly. How many times? Well, there are 50 pairs of numbers between 1 and 100, so if we do 50 times 101, we get 5,050. And so we like to have a formula for this. And so whatever your total amount of numbers are, n, and if you add 1 to that, and then we multiply by how many pairs of numbers we have, n divided by 2, last number plus the first number, times n divided by 2. That's what we're going to be dealing with. And so we've got some formulas for special series so that we don't have to add up a bunch of numbers individually. So when you add up the integers, notice, and I'm going to use this one just because this is exactly what we've been dealing with. When you put in 1, 2, 3, 4, 5, 6, all the way up to n, we were just adding up those numbers, 1 all the way up to n. You use this equation. Now, what I wrote here was sort of what we modeled, but this is sort of what was in the book, so I wanted to make sure we had it in this form, just not to confuse anybody. So this is number of pairs of numbers, last number, like our 100, plus our first. If we kept adding the same number over and over and over again, in this case if we kept adding 1, and notice if you take I and start at 1 and you plug in 1, 2, 3, there's nothing to plug it into, and so this is really just going to be 1 plus 1 plus 1 plus 1, very boring, n times. And so if you add 1 n amount of times, the total is going to be n. If you add it 4 times, it's going to be 4. If you add it up to 5, it'll be 5. And so we're going to use these formulas and do it both ways. 1 plus 1 plus 1 plus 1 plus 1 is the same thing as if we started at n equals 1 and we had no place to stick the n and went up to 5 because there are 5 ones there. That's equal to whatever this is, 5. And so we can check that 1 plus 1 plus 1 plus 1, sure enough, is 5. So let's try another equation. We're adding up all the numbers from 1 to 10, and so I'm going to use a different index, meaning I can use k equals 1. And I'm going to plug it in, and this is going to be whatever this number is, because first term, second term, third term, fourth term, so whatever I plug in there, all the way up to my 10th. And so we're going to use this equation where we have 1/2 k plus 1. And so notice I just changed the value of whatever we had. Because I used k, I'm going to use k here because it was I up here. Whatever. Really it should be whatever n is. So 1/2, 10, 10 plus 1. Half of 10 is 5 times 11. So you get 55. And so you can add up all of these numbers, start pairing together 2 and the 8, 1 and the 9. Find easy ways to pair them together. You got 4 and 6, 3 and 7. Those all add up to 10. You got an extra 10, you got the extra 5. So those two add up to 55, and so it checks out. And they get more complicated as you start adding all the perfect squares. So if we start adding up 1 plus 4 plus 9 all the way up to, and so what we have here is I equals 1 up to 1, up to 6 squared. And so I being squared is 1/6 n plus 1 n plus 2. This equation right here. One thing to memorize for sure. And that's going to be 1/6 times 6, which is our n, number of terms, 6 plus 1, 6 plus 2. So 1/6 times 6 cancels out, and then you're left with 7 times 8, which is 56. And so you can add those together too, you're going to get 56. So what I want us to do is now go back to our original jobs and look at how much total we would have. So a while ago we plugged these into sigma notation, and our first job started at 1, first day, I equals 1. Our nth term was 69 plus n, so that on your first day you made 70. And we want to know for your 40 days. So what we're going to do here is split this up so that we have, well, what if we have the sum of 69 and we have the sum of n from 1 to 40 and 1 to 40. And so what we can deal with this is we can take the 69 and multiply it by the 40, because we're going to add 69 40 times. And here we're going to use our special sum, and whatever n is, and we're going to have 1/2 40, 40 plus 1. We're going to multiply those together, 69 times 40 plus, that's 20 times 41. And so you make a total of 3580. Now the second one, we have 40 days, and actually I guess I should make this an I just because we're plugging in I into there. I equals 1 to 40, and we had n squared over 100. So what I'm going to do is I'm going to take out the 100, and that's the same thing as 1/100th times whatever we get as a result of adding all these numbers up. N squared. And I did it again. I should make that I squared. So 1/100th times our 1/6, 40, 40 plus 1, and 40 plus 2. So 1/100th, and actually let's just type this in. 1/100th times 1/6 times 40 times 41 times 42. $114.8 days. Sorry, $114.